Yeah, we're now recording. Thank you, Craig. Over to you.
Yeah, okay. Thank you. Let me just get rid of that. Yes, I think the idea behind this was when we had the previous discussion together, it was sort of raised that there would be a benefit in some expert inputs to answer some questions. And, not just around climate change, but certainly from my side on the law side. And, this is an interdisciplinary approach. So it could be really helpful. And it struck me for this group that it might be an opportunity to talk about climate change just in and of itself and any questions that people might have of whatever level. So that's why I asked Professor Sheffield to come along, who is an expert in the modelling and many other applications of that modelling. And I've worked with Justin on a few, and I'm more perhaps on the social context and the vulnerability side, and we've worked together. So I thought between us we could do it. Justin, would you be happy to go first with your slides, or whatever it is you feel? I'm just going to do a 5-minute myself after you.
Yeah, I can do that. I think I probably will talk for about 10 minutes, but I'll try
Yeah, that's fine. Yeah.
Try to go quickly.
5 to 10 is where I'll be. Yeah.
Okay, let me. Oh, I think I need.
Should be possible now. Try again.
Okay.
Yeah, we used to Teams, so I get confused in this. Yeah, we can see that. If you want to make it full screen, that might.
Okay. What do you see? Do you see the notes as well, or?
Yeah, we see the slides at the bottom.
Okay, let me do it as just do it as a normal slideshow. Okay.
Yeah, that's better. Thank you.
Yeah, okay. All right, good morning, afternoon, everybody. So, yeah, I'm Justin Sheffield from the University of Southampton, and my background is in climate change and water. So trying to understand the interactions between climate and things like floods and droughts, water resources management, and many of the sectors that are dependent on water. So that can be energy production, agriculture, health, and so on. So I'll touch on a few of those topics as we go through. So what I wanted to do today was just give a kind of a taster almost of a few issues around how we understand climate change, the kind of tools and approaches, data that we use to quantify climate change and its impacts, and the complexity of identifying kind of solutions, especially on the adaptation side, in the African context. Some of these thoughts do apply to other regions, of course, but the focus here is of course on Africa. So I'm gonna talk about the lack of data, which is a real challenge in some areas of the African continent. Uncertainties in modeling climate change and its impacts, and how that kind of propagates to our ability to think about adaptation, and also the key role that water plays in this, because of how important that is to various sectors on the continent, and especially around transboundary issues. There's a lot of shared water resources in terms of surface water, rivers, lakes, but also groundwater as well, which is an emerging topic that needs kind of more focus on. And then a few resources and references that I won't talk about, but they'll be in the slides, and I assume those can be shared. The picture on the left is the Kwiseb River in Namibia. And you can see the Dune Sea in the background. And this was the first time this river flowed for about 7 or 8 years, which happened last year, just for a bit of context there. So I'll go through these three topics. So firstly, the lack of data. So it's pretty well known that ground data, so that's things like weather stations or stream flow gauges, these are really crucial for understanding how the climate is changing and the kind of impacts on things like changes in floods and droughts and impacts on different sectors. Um, those ground networks in Africa are quite limited and also declining as well. So that makes it really challenging to robustly quantify changes in climate and risks around things like floods and droughts and how those are changing as well. So the figure on the right shows the distribution of weather stations that are supposedly regularly reporting and also quality controlled. So we can use them for things like weather forecasting, but also understanding longer term climate changes. And you can see there's many parts of the continent where there are very few gauges. And this figure here just shows in the red crosses stations that were still active in 2017. So the black ones are generally not active anymore. So you can see large networks where we're starting to miss data. And you can see how this has changed over time on the figure on the far right. So the number of weather stations, quality control weather stations since the 1950s. And you see this precipitous drop in the 1990s that's happened across many countries in the continent. So this is really problematic. Only about 10% of the world's ground-based observation networks in Africa, and that's 54% of Africa's surface weather stations cannot capture data accurately. And if you think about the variability of climate across the continent and also the size of the continent, you would expect to have at least double that density of gauges to really kind of capture that variability. Another example is on the bottom left here. This is streamflow gauges. And one issue here is that you generally have different agencies in countries that are collecting this. So it would be the National Hydrological Agency that would be collecting streamflow data. You have the Weather Service in the country that's probably collecting the weather station data. So they're hopefully often talking to each other, but not always. So streamflow gauges, that's an issue as well. You see large parts of the continent and individual countries where there's no readily available data. And when I mean by readily available, this is available to, say, the research community to actually do assessments of how climate is changing and hydrology is changing. And a lot of these gauges have gone into are not being maintained anymore. Many of those stopped providing data in the 1990s for various reasons. So does this matter? Yes, it absolutely does. It increases the uncertainty in estimating climate variables and risks and their changes over time. And this can lead to under or overestimation of trends, misrepresentation of those risks, and therefore the required adaptations. So the example over on the right here is focused on the Congo River Basin, so quite a large river basin, which has had a history of decline in gauging networks in terms of weather stations. So if you want to look at, for example, how is rainfall over the Congo Basin or subregions changing, that has a massive effect on the uncertainties in that estimate. So the red line is the estimated error when you have this decline in the number of and the density of those weather gauges. And you can see it starts to reach about 30% by this estimate and has probably gone up even further if we updated this figure. So this is also problematic for many other applications. So early warning of hazards. So whether that's weather hazards or floods or droughts, real-time attribution of events, which is also important, model development, so how we develop and test our climate models, and knock-on effects to things like policy and investment, and also contributes to the general digital divide in Africa with the rest of the world and continued lower regional capacity. Here's an example that shows that much more data is actually available. So this is Kenya. So we tend to use gridded data products to do climate analysis to understand how things are changing, and that comes from source data of readily available data from stations. So that's the middle figure. But if you go to the Kenyan meteorological department, you'll find that there are actually hundreds of stations or data available for hundreds of stations. But a lot of this is not available because it's not digitized. It's often not in real time. There are real issues in trying to extract that data. And often it's not at the resolution, so we'd like it at daily or sub-daily that we actually need to understand extreme weather events. And that's perhaps a best case scenario in Africa, along with, say, South Africa. That's also true for places like the UK, where we have lots of data that's digitized, but even more data that hasn't been digitized, and we're losing that every day. Now, the second part, so we have uncertainties and lack of data. We also have uncertainties in how we model climate change and its impacts. And we tend to do this using climate models that then propagate their information down to impact models. So that could be a hydrological model, a crop model, or some kind of water resources model that's simulating how we manage and operate dams, for example. So we have this very complex set of models that allows us to understand and estimate climate change, but also potential adaptations at the bottom of this kind of triangle. So each of the choices that we make in this modeling chain has uncertainty embedded with it, and that uncertainty propagates through that chain and generally increases. So we can think about choices about how we might think the future society will change. That has implications for what the greenhouse gas emissions are, and those are uncertain as well. We would then use that to force a climate model, and that climate model, there's many climate models available, and their structures can be different. We'd also like to downscale those to a regional scenario so we get more detailed information for a particular regional country. We'd also like to look at the impacts, so that could be crop, hydrological, health impacts, and so on, and those adaptation responses as well. And as we make those choices, we can end up with quite different answers at the end. So that uncertainty propagates through the whole system and makes it quite challenging to actually say, well, what is the right kind of adaptation response given our expectations of a particular future society. One of the other challenges here is also that the lack of knowledge about African climate. African climate, as I mentioned before, is highly variable and of course changing, but there is less known about the African climate than there are in other places around the world. And this is a lot to do with the funding for climate research. So the figure on the left here just shows that massive difference between funding for climate research for the whole world versus that for Africa. And a lot of that African climate research is done by people outside of Africa as well, which is a real problem in terms of the kind of the capacity as well. So I'll give a couple of examples about how this uncertainty in climate modeling and impact modeling, the kind of implications of those. So this is an example of the Congo Basin. So a huge swathe of the African continent, one of the most important basins in the continent, and the largest in terms of the kind of flows, with huge biodiversity and also lots of security issues going on as well. So the figure on the left is mean annual rainfall over the Congo Basin. And if you can see my mouse here, all these little panels at the top are individual climate models. And down on the bottom right is what the observational estimates are. So if we take all the rain gauges over the basin, which are few and uncertain, this is what we think the annual rainfall looks like. And you can see that the climate models can kind of capture the higher rainfall across the basin, but it's very highly variable across the climate models, with some overestimating that annual rainfall by perhaps up to twice as much, and sometimes underestimating as well, with huge differences in the spatial patterns as well. So the models are biased. There's a large variation between those models, and this is really important because we need models that we can have some faith in, that they're replicating historic climate, so we can actually use them to understand past climate change and variability, but also it's a necessary condition for plausible and accurate and robust future projections. So understanding how things are going to change in the future. We can't necessarily use a model that doesn't replicate historic observations to say something about the future. This is also highly dependent on the individual models, but also we would like confidence to be drawn from using multiple models the tendency for it's like the wisdom of the crowd, the consensus of multiple models tends to give us better results than if we use an individual model. And the figure on the right just shows the relationship between the skill of the models versus the number of models. So if we look at one model, then we might find an individual model that's quite skillful and many that are not skillful. And as we tend to look at more models as a consensus, then that skill tends to increase and that variability decreases. So there's real challenges in terms of the models that we choose and how skillful they are, with implications for understanding past variability in climate, but also what's going to happen in the future. And here's a real good example of that, something called the East African climate paradox, where we've seen over the Horn of Africa declining rainfall and more severe drought events over the past 30 to 40 years. So if we look on the figure on the right, that red line there is the observations. So you see this decline, you see a lot of variability, perhaps a little bit of an improvement over the last kind of 10 to 20 years, although we need to kind of update this observational record here to the current date. But yet we see this kind of overall decline, so a drying over the region. Now, if we look at the models, so the climate models, so if you focus on the green and yellow shading, and then the average of that is the green line and the yellow line, they tend to not pick that up. So they tend to show kind of neutral, not changing conditions historically. And then as you look to the future, it's quite optimistic in terms of projecting increases in rainfall. So if you think that is robust, then you might put plans into place to adapt in a certain way for more rainfall in the future. So, but this is disconnected from what we see in the observations. Now, if you take a climate model where you force it with observed ocean conditions, so sea surface temperatures, so that's the blue line and the blue shading here, that actually follows the observations much better. So that what we can conclude from these studies is that normal climate models that simulate the land, the atmosphere, and the ocean coupled together tend not to reproduce the historic observations, and therefore there is some doubt about their future projections. Now, the problem with running a model with observed sea surface temperatures is that we don't have those in the future because we don't have those observations yet. So this puts a lot of doubt into projections of future climate change in this area. And there are other examples around the world like this, where we have this disconnect between models and observations. And that gives us much uncertainty about how we can respond to that in terms of adaptation. Now, the third part is around water being a key driver of climate impacts and adaptation. And the reason for that is half the world's population experiences some kind of water scarcity or severe water scarcity for all of the year or part of the year. And that's because of environmental pressures, too much water, so floods, too little water, droughts, or too dirty, so water quality issues, but also societal pressures as well. So that's coming from economic or governance challenges. So you can see on the figures on the right, this is just a snapshot from the 1980s and then 2015, so still over 10 years ago, showing the distribution of water scarcity in different kind of thresholds. And you can see that a lot of the population is actually exposed to water scarcity either for the whole year or part of the year. And that's to do with access to water. It's also to do with climate variability. And especially in some of those kind of more marginal climate places, so in the Sahel, for example, those edges of monsoonal systems in particular. And water scarcity impacts on multiple competing sectors. So as I said before, agriculture, energy, industry, urban municipal supply, health, sanitation, ecosystems, and so on. So water is really important for those compounding and trickle-down impacts of climate variability. And reviews have shown that the majority, so about 60% of all adaptation responses documented over the last 10 years, are about adapting to water-related hazards. So droughts, floods, rainfall variability, extreme storms, and so on. And water actually features prominently in NDC pledges as well for various countries. So water is kind of central to this challenge. And especially when we think about transboundary systems. So these are systems that span political boundaries, And understanding climate change across these boundaries is really important because it becomes a shared problem in terms of managing and adapting to climate change. So the figure on the right shows the 63 transboundary river basins across Africa. So that's the colored shading. So you can see the Lake Chad Basin, you can see the Nile Basin, the Niger Basin, Congo Basin, and so on, that share, maybe 8, 9, 10 different countries share those basins. So there are challenges around managing water resources there. The figure also shows in the kind of shading, you can see some examples here of aquifers, so groundwater resources. So there's about 72 mapped transboundary aquifers across the continent. Now there's also transboundary lakes as well. So for example, Lake Victoria is shared in some way by 5 countries, but has lots of challenges in how that is managed and the resources used. Now there are transboundary agreements in place for many, especially of the surface water transboundary basins, but there's real challenges about how these agreements can be maintained while the climate is changing. So how can you allocate water when the climate is changing and uncertain? Now, groundwater is really important because it supplies water for 75% of the population in some form, often the most important or only supply of water. And that demand is growing, especially to adapt to climate change, where we're seeing more severe droughts and to provide food security for populations. And it's only recently that management of those transboundary aquifers has been recognized as a central component of water governance and therefore of adaptation. Now, just one example of this, which is of course very well known, is the Nile River Basin, and it's a very complex problem that goes back as a history going back for a couple of centuries and perhaps more, back to colonial days in the 1920s, when the first agreements were put in place between Egypt and colonial Britain essentially. So there is some legacy of cooperation, but ongoing challenges over water sharing, especially with the upstream countries from Egypt. And this has been complicated by the building and filling of the Grand Ethiopian Renaissance Dam, or GERD Dam, which is, you can probably just see it's the green triangle on the map on the left there. So this has potential and will transform Ethiopian development, but of course it has impacts on downstream countries, which they are not particularly happy about it. So the question is, how can you actually fill this dam and then operate it under climate change, which is quite uncertain, as I showed a few slides ago, to satisfy the demands of water, energy, food, economy, and on it goes in different sectors under this changing climate for multiple countries. So the figure on the bottom right there shows a number of metrics in terms of GDP for the different countries, in terms of power production essentially for Ethiopia, and then downstream impacts on hydropower production, but also irrigation as well, which is important for national food security. And you can see each of these lines is a different way of operating the dam under climate change scenarios as well. And you can see there's very different outcomes for each of the countries and each of the different sectors. And this is not every sector that's impacted as well. So it's a simplified version of a complex problem. What you can see is there are some favorable designs for Egypt, some that are more favorable for Ethiopia, and again for Sudan as well. But what you can do is you can come up with a compromise solution. So that's that kind of light blue cyan color, which, of course, there are trade-offs across these different metrics. What it does show you is that there is a huge complexity in this system, this transboundary system. We're not even thinking about transboundary aquifers here. This is just about surface water that needs to be addressed to really understand how we can adapt to future climate change. So I'll stop there with just a few points in summary. So lack of capacity is a real challenge to quantifying, understanding, and adapting to climate change. So I mean things like lack of capacity in data that's available, data that's collected, technology, knowledge, expertise, and the research literature. And this has implications, I think, for national responsibilities about adapting to climate change. Models are really important for understanding climate change, attributing extreme events to climate change, and also projecting what's going to happen in the future and its impacts. but these are complex and uncertain, and there is definite potential for over or underestimating those risks. And I think water sits at the heart of the climate change challenge for Africa and other places, especially around transboundary issues that really makes adaptation potential much more difficult when you have to think about downstream, upstream effects and cooperation. So there's a real, in my opinion, a call for careful evaluation of the evidence and challenges and more investment, of course, in data collection, data rescue of existing data, paper records, for example, data sharing, and certainly in climate science for the continent. And arguably, nations should be investing more in transboundary issues. So I'll stop there and stop sharing.
Thank you for that, Justin.
Oh, apologies. I think I talked a bit too long there, but there you go.
Famous academics. Can we have, I thought actually, let's have questions to Justin and then I'll do something on risk assessment. I mean, my main thought is that remember that adaptation is always going to have to be around uncertainty as well. We never know exactly what we're adapting to. So any kind of adaptation has to include some sort of wiggle room to, we don't know that future. So uncertainty is key. Joanna, and then there was Joanna Joyce left a question about the paradox. And then Dinah, you've put something in there. We'll come to you.
I don't have to say anything about it. As Justin was talking, I was highlighting like links to the charter. So if one was going to argue this directly with a connection to rights that are already articulated and protected in the charter, those are in my comment there. So
great. Okay. So Joyce, you went. Let's ask Joyce because you put a comment in first. Are you quite happy? And then we'll come to Joanna and then Sumaria.
Yeah, thanks, Craig, and thanks, Dina, for organizing this. Thanks, Justin, for this presentation. So, no, I put that point because I was listening to Justin's presentation, and I was just this was just a question about the paradox, and I mean, there's the East African paradox that has, of course, been in the scientific arena for discussion for a long time, and we've seen that the March, April, May rainfall in East Africa, which was really linked to the paradox itself, we already see a recent recovery in the rains that appears to challenge the paradox to some extent, not entirely. So I think the main issue there is really about the sort of the complexity in model simulating the East African climate. So it's just really about the model sort of capturing the complex interaction of the local convection, the regional circulation, and the remote teleconnections that drive East African rainfall. So I think that's the main point there, but there's a lot of discussion about the paradox itself. But the main question that I wanted to ask Justin is that I see that his presentation has highlighted and focused so much on uncertainties and challenges of conducting science in the continent. But I think it would also be helpful to emphasize how the existing body of evidence can already be used to support the court to make the advisory opinion. So there's already substantial evidence available that can be leveraged to support the court. So of course, I understand that these challenges exist in the African continent, but I don't think we would just want to focus on the uncertainties of models and doing the science and sort of the transboundary risks and stuff like that, but also looking at what already exists that can be used to support the courts. And because basically, of course, we are seeing these impacts affecting communities in the continent who are the front line of the climate crisis. So I think I'm a little bit nervous to just talk about uncertainties and challenges and limitations in the sense that it might not be able to help these communities or help the court to issue an advisory opinion that can support the African states or the African community in general to respond to the crisis. And I think, of course, you highlight very critical points of investing in data infrastructure, which is very critical. And I think that one should be part of the advisory opinion to basically encourage African states to invest in data. So to invest in maintaining existing stations, but also really putting up, improving the network of stations to help. And that will go a long way in anticipating risks and preparing better for risks, but most importantly, understanding the climate system and how that is changing. So I thought that was a main point that I wanted to make. Thank you.
Justin, did you want to come back on that point?
Yeah, I'll quickly respond to those 2 points. Yeah, I don't want to use this talk to say, oh yes, there's a bunch of uncertainty and therefore we shouldn't do anything moving forward. I think there's the uncertainty really should compel nations to invest as Joyce was saying. So it's really about kind of getting better data to really make those assessments even more robust. There's of course there's uncertainty. You collect more data, you do more climate science, you hopefully reduce those uncertainties, and that's coming off the back of a huge amount of existing evidence, body of evidence that should be drawn upon, and much of that evidence does show that things are changing, and they're changing because of climate change. So I don't think that dispels that. It's just recognition that there is uncertainty, but there is something we can do about that uncertainty, and that's to collect data, invest in capacity to do climate science. And the other thing about the East African paradox is that yes, problem with climate studies is they do actually go out of date quite quickly. So if you're not updating those trends, then things can actually change. I think what I can say is that the observations are showing a quite strong connection between sea surface temperatures in the Indian Ocean and the Pacific, which the models are not picking up. Those couple models are not picking up. Now, of course, they're not potentially doing a very good job of what's happening on the land with those convective systems and the interactions with regional climate, but the remote teleconnections are fairly robust in the observations, and the models are not picking those up. So there is a challenge there, whether they're picking up the observed rainfall trends in any case. Okay,
Someria, would you like to answer? Well, we did have 2, but one hand seems to have gone down. Soumaya?
Yes, thank you so much, Craig and Justin, for providing this presentation today. My name is Soumaya Arslan, and I'm with Child Rights International Network, and I'm not a scientist at all. So I'd really, I'm a legal professional. I think in legal terms, so don't shoot me down. This question is too dumb. But what I was wondering is that scientific kind of models and pathways have been based on efficiency and on growth, right? How can we best get to a point of net zero to 2050 by being as efficient as possible, by doing as much as kind of day-to-day business, but reducing that kind of the emissions that we need to bring down. So my question is, from a child rights perspective, from a justice perspective, from a legal kind of common but differentiated responsibilities, equity, are there any scientific basis to kind of point to that says that they actually need to do more because the existing models are based on growth and efficiency and more on economic value rather than the protection of human rights and the kind of equal but differentiated, responsibilities of states? Is that question clear?
Yeah, I think so. I think the example about the Nile River Basin is probably the best way to answer this somewhat quickly. So that study that I was involved with was somewhat groundbreaking in the sense that they were bringing together models that simulated agricultural sectors, energy production, national economies, and even energy interchanges across the region as well. So a very complex set of modeling and data analysis to do that. But it didn't take into account anything around equity, social justice, thinking about communities or anything like that. It was very much, as you say, about production, optimization, GDP, and things like that. And I mean, that's the massive challenge that I see is how you can incorporate those kind of things and even put it into a metric, which in itself is a very difficult thing, and then try to think about the trade-offs between those. So if you are going to optimize, say, power production and irrigation across those three countries, what are the implications for communities across those countries as well? And I think we're a long way off in being able to model that and understand that, let alone have data to kind of characterize it. I mean, Craig may have some answers for that, but it will be interesting to see how those kind of things can be brought together in modeling frameworks, so we can actually look out into the future and say, well, what are the options, and what if we do something that's not about optimization of energy production and finances?
Yeah, I think it's fair to say, actually, just to add to that, the models that Justin is showing, are physical atmospheric models. They simply respond to the drivers that are input. The question you're asking is, if we're looking at scenarios of the future states, should we be thinking about, not driving more carbon dioxide into the atmosphere, of course, but these models are simply there for us to look at responding to if we do that, if we don't do that, if we moderate in this way, if we lean on renewables. So they're sort of, if you like, a more objective, they're a more objective response. What I think you're addressing, and perhaps that's a bit more I am interested in, is the future scenarios. And those are driven. It's what we plan to do in the future, as opposed to the models themselves, which are physics, essentially. So there's a lot of work to be done thinking about, what kind of plausible future state society can take on. And I think that's what I may do a very quick, mine's relatively quick. If I may, I'll do mine. You'll probably see yourselves a lot at the moment. This is all really baffling. Can anyone see that? Ooh.
Yes, we can. Perfect.
Good. Whew. Okay, so hi, I'm Professor Craig Hutton. I work in the same department as Justin, in the School of Geography and Environmental Science. I'm writing an amicus brief, leading an amicus brief, where we're looking at coastal impacts and using a case study in Ghana. I work predominantly, and I'm the director of something called the Sustainability and Resilience Institute here. I work predominantly with climate modelers such as Justin and others. I'm interested in their outputs, but I'm very much interested in how you take that and how does that have societal impacts, and what are the consequences for that, predominantly around livelihoods and rural livelihoods. So there are many who will use that information in different ways, as Justin's mentioned, for energy, but I'm particularly interested in primary livelihoods like agriculture and fisheries, and trying to understand how climate change and this uncertainty has an impact. And I thought one of the things I might talk to you about is that the IPCC uses something called the risk framework. Some of you will be very aware of this, and I apologize if that's the case, but I do think it's a good way of thinking and helping us think about the impacts, how you translate those climate changes onto the ground. And in principle, we can think of the risk of climate hazards. So this could be anything like flood or drought or salinity or heat waves or disease driven by. We can think of risk as being the hazard. What is the thing that's happening? And Justin has models on that. Exposure, where is it happening? And therefore, what populations and assets are exposed? And again, the kind of models we see there are helpful, but then we need to understand distribution of assets and distribution of populations and livelihoods and things on the ground. But we also need to understand, and I probably work most in this, in vulnerability. And that is who it is actually happening to. What is the nature of the people and peoples that this is happening to? And we can think about hazard, and this is just a way of organizing our thinking, of bringing the first steps towards that integration we were just talking about, where we need to understand how it translates to society. The hazard, we can think about its probability of occurring, the magnitude of it occurring, and the duration. The exposure, we model these things and map them, the spatial occurrence, assets and people. And of vulnerability, and this is where I'm particularly interested, we think of it in three ways. We think of it in coping, the immediate impact. Can people survive? That's the kind of thing you do is sandbags or moving your house or getting out the way of a flood. Literally the first few hours, your immediacy. We think of your sensitivity or a community sensitivity, and that's the degree to which your livelihoods and your assets are sensitive to the event that's happening. If you are, let's say you're a lawyer, it may be that this can happen, but you retain your livelihood. Whereas if you're a farmer and your fields are destroyed by this, you're highly sensitive in that way, or your housing is highly sensitive. So we think about your immediacy of coping, which affects everyone who's exposed in a way. Sensitivity begins to differentiate between people and usually their sort of livelihoods and their ability to access help, etc., perhaps hospitals, emergency services. And then there's the longer term adaptive capacity of those groups of people or individuals. And adaptive capacities are really important. Longer term thinking of how do we respond in the longer term. So we can think, like we say there, coping is response to immediate impact, sensitivity, almost the problems that are caused. And adaptive capacities, what are we going to do about it? And this is things like social capital, human networks, how we support each other. It can be how we're able to use our assets like bank accounts, or we may also have social assets like people we can go and stay with, but you may also have a house somewhere else. You may have road access and good road supported network, which helps you move. And things, particularly in the West, we often think about things like insurance as being part of your adaptive capacity. So we try to break down the vulnerability of people, which is often represented as a primary case of poverty. Poverty has a very big impact on all of these, not exclusively, because some people who are poor can become less sensitive with time by having boats and houses on stilts and things as you get you begin to adapt. But broadly speaking, we think about these as poverty, and the point was made earlier about equity. When we want to think about our adaptation, and this is the kind of thing that we're expecting the courts to think about, their people's ability to cope, the sensitivity of their livelihoods and land, and the capacity to get back on their feet and to adapt to the environment. These are often thought about as being driven by poverty, and we need to think about equity. There are people who are, just because they're exposed to the same event, does not mean all people are impacted in the same way. So vulnerability is an extremely important point. And we can see this through the sort of, if we look at the disaster cycle, this is just about the key types of social capital we might think about. But in a simple way, pre-event, we can think that people's adaptive capacity, this was specific to health. I was doing something on health, but it's true of any others. Adaptive capacity, we can think about people have a certain integration of their past. They have adapted to some degree if they're capable of doing so. They may be too poor. During the event, there's coping. Immediately post-event, there's the sensitivity and the impact on them. And that feeds in. How much damage is done here affects the capacity to respond, which comes back to the beginning of the cycle. So what we can see is a kind of progressive spiraling down, or if we intervene at these points, say adaptive capacity, we enhance the adaptive capacity, our coping is better, our sensitivity, there's less damage done, we are therefore left with more to adapt, and so on. You can get a virtuous spiral. So we need to think about And that's a lot to do. And I think this is where the government and policy can intervene. And we need to understand which of these effects and the degree to which these effects work with each other to understand the degree to which and where government can impact. And again, it does raise that point about equity. And it does raise the point about poverty. And we need to think about these things as we think about scenarios of the future. We need to look at the fact that under different scenarios of the future, if we carry on the way we are with just economic thinking, we're going to see negative impacts on these. If we invest in community-based capacity building, equity issues, gendered issues, intersectional issues, we're going to see, which we know are more effective, we see virtuous spirals, and they're not only linked to economic growth, they're linked to social growth and those contexts. So this is something I'm interested in. And then when we think about the fact, it's as a sort of corollary to what Justin was saying, is that when we think about models of any kind, and this is true of climate models, but it's true of our social models and understanding, we really need to understand that another factor in the uncertainty, so yet more uncertainty, is they're not linear systems. And this is just a classic, simple example of the resilience framework, which looks at tipping points. And if we think of this as sort of a community, a social, community, a socio-ecological system, we know that you can push that system and it might return and stabilize. So what you're doing here is you're pushing it, and its sensitivity, the damage, let's say, of flood happening to a community, can push it, but it recovers. And if you push it this way, it recovers. But you only need to push it to a certain point where it finally recovers. But if you push it even fractionally beyond that point, the whole system changes and you get a new resilient state, a new cup or valley here that it sits in. And it can take a very small amount of change at that peak before, say, agriculture is no longer feasible and the whole area is abandoned and migrated. And it's not a linear relationship. And a lot of the systems modeling we do is about trying to understand where these peaks are. I think this is true in physical climate models as well. You can drive the model, and then suddenly there's a substantive change and the whole system changes. And that's into a new state. And we need to really understand it's then extremely difficult and not a matter of just a little push to get that back to where you were before. It may indeed be impossible. So there's more uncertainty there as well. I'm going to leave that as that and come back to you, if I may, and stop sharing. Right. Dino, any thoughts? What would you, we should have an open chat perhaps.
Thank you, Craig. So one of the things that I've been sort of noting in my comments and thinking about linking the provisions of the Banjul Charter with questions around vulnerability and adaptability is also sort of awareness about the rights that are missing in the African Charter that might be important to sort of think about how one addresses those in submissions to the court. So kind of most obviously, we don't have a right to water in the Banjul Charter. We don't have a right to food in the Banjul Charter. There is no right to housing. And all of which have been the center of arguments around vulnerability and adaptability in other rights jurisdictions. So I think kind of addressing these issues within the framework of the Banjul Charter requires a little bit more creativity. And I think that means using the provisions that there are, including rights to health, rights to be protected from discrimination for women and children, obligations. There are heightened obligations on the state to protect women, children, the elderly, and the disabled. And one of the things that makes the Banjul Charter a little bit different from other human rights instruments is it has very interesting provisions relating to family, which kind of may or may not be helpful for thinking through obligations. One of the things that's interesting about it is it's not just state obligations to the family. States do have obligations to protect. I can't remember the wording exactly, but it's like the moral well-being, but also health of the family. But individuals also have obligations to their own families. And it seems to me that that is very, that might be open to some useful interpretation in terms of drawing attention to adaptability measures and arguments one might want to make in one's submissions. Back to you, Craig.
Yeah, that's a really good point in terms of how we might choose to address our amicus. I wonder if one of the rights that's missing is the right to a reasoned level of protection against uncertainty. Because one of the things that is coming out, always is coming out, is there is uncertainty. There's certainty that there's change happening. I don't think we're uncertain about that anymore. But the nature of that change and how it filters down through Justin's triangle isn't going to go away. It's not a case, we need to do more measurements, we need to do, but with society, that there is always going to be, we can minimize it, but there will always be uncertainty in the future. That's just the nature of complex systems. And so we probably need to emphasize that we can't just take, well, here's what it is, and here's what we do know, and that's it. There is, in a way, a right to protection from a potential dynamic range of future states, that we need to not just have, well, this is what we can prove, so we'll protect you against this. We need to be able to say, I think, there is a range of possible futures, and there always is in complex systems, and therefore we need to build in a buffer. And that makes, and we do that in every other system that we do, building bridges and things. We don't just say, well, this is the minimum weight. We say there is a range of plausible, and we're going to double that, and that's tolerance. And I think what we have to say is it's not enough to do the minimum because things could be worse. And there are co-benefits to adaptation anyway. So trying to put in that people have a right to a reasonably secure future, not a minimum for the future.
I think that's, yeah, and maybe to add to this point that Craig is making, because I think it also connects to some of the points that Justin was making. You know, both the presentations have talked a lot about uncertainty in what's coming, uncertainty in the modeling, uncertainty in the data. And the argument is not that this should be, my understanding, what Justin and Craig want to communicate is not that this is a call for caution or inaction on the part of African states, but rather the kind of response to that should be sort of greater action at a higher level of response.
And more covering plausible, reasonable. We know we can't put everything into it, but we can say that there should be a much more whole response and of substance, because there's every possibility it's worse than what people are thinking, and things combine with each other in ways we haven't yet thought of, like political unrest can come from these things. There are lots of ways that these things amplify, and that therefore now is the opportunity to prepare for a future that is uncertain.
I see Joyce has her hand up.
Sorry, Joyce, yes.
Yeah, so I wanted to absolutely concur with those points, Craig and Dina, saying that, and thank you so much, Craig, for your presentation. With all the uncertainties, especially in understanding the climate system, with all the challenges or limitations that are associated with that, is that we should do more than the minimum for sure. So basically, we know that as a globe, we are surpassing the 1.5 target that we put for ourselves. This mechanism that we set as a planet to help us avoid these dangerous impacts of climate change is that we really need to do more than the minimum, the basic. And for sure that the situation is worse than we think or worse than we understand, and especially with all these challenges that have been highlighted by you and Justin. And so, especially on the issue of vulnerability, which I think has to come a bit more clear, listening to you both, is that we are seeing escalation of impacts. So that means that that is likely to dampen vulnerability, because if the adaptive capacity is not good, it means that societies are going to be continually impacted by extreme events, and countries would have to dig into their pockets to actually respond to these escalating impacts. And you can see there's a huge debt burden already in the African continent. So there's a lot of diversion of funds that are meant for very critical services being used to respond to disasters. And what that means is that these countries are likely to sink even more into debt, and it will become very difficult for communities to actually respond to these escalating impacts. And so it means their vulnerability as well is continually sort of dampened, or like it becomes very hard for them to adapt. And so that's why really these rights that Dina is trying to point out about rights for communities to adaptation. So the duty of states to actually protect communities from these escalating impacts is something that should be very much be part of the advisory opinion that comes out from the court.
I think that's really. Oh, sorry. I think that's a really good point, Joyce. And to add to your point, I think one of the things we often think is that by investing in communities and adaptation in that, we're not investing in the economy. It's like, oh, we can grow our economy, or we have to go and do this. This is the economy. These people are the economy. The fields that they grow food in, the factories that they work in, the coast that tourists go to, whatever, you're protecting your people and economy. This is growth. It's a different type of growth, perhaps, but it is growth, and you invest in protecting your future country. And I really would like in the amicus to get away from saying there's this economy in this world over here, which is, and then there's these people, and you must choose between, having a prosperous country and just protecting. And this is the new economy. The sustainable economy is the future economy. So it's an investment. It's not just a cost. It's an investment. And adaptation should generate co-benefits and growth, and it's rarely a terrible thing unless we build a wall that's in a silly place or do something that's, sometimes things you pour in concrete, but developing strategies and raising the capacity of your community. These are how you underpin a successful and prosperous community. We have this divide, and I think that's been propagated by some people who don't want to do that. They just want to invest in. We need to say this is the economy. These are the people.
Yeah, but I think as we focus like in country or within countries to think about how do you protect your communities, I think there's also the external debate about how can we like an international community, and especially from a justice side of things, like how can we support African states to actually protect their communities? Because some of the disasters that are responding to are not actually responsible for this. So like we are living in a crisis that most African states are not responsible for. So as much as we're talking about within systems or change in systems within countries, we should also talk about like how can we have a concerted effort to support countries to actually actualize that.
Yes, yeah, and that's economic. But I think part of that is saying this should be part of your economic strategy of growth, but a different kind of growth. I accept that. But if we want the African states to be serious about responding to this, we need to make the argument that this is in the long-term benefit of the country, the whole country, the people, that I think there's a bit of an argument that it's like money you could be spending somewhere else and it's a bit wasted if you didn't, you're just going and doing these things. But actually without people and agriculture and roads, there's no economy, there's no growth. So you're doing what your country's central thing is: defend your people and grow its economy. This is exactly that process.
Maybe something just to add to that. I know we're over time, so we're gonna have to stop. But like one of the things that I think is important to think about doing as we're writing these amicus briefs is that we're not only engaging with the court and looking for a very progressive, helpful advisory opinion, but this is also an opportunity to provide states with the kind of arguments that they might need for, as Joyce says, their engagement with the kind of main countries who are the source of these emissions. But also, something that Justin spoke to me about when we were first talking about this was that the uncertainty that he's flagging up gets used as a kind of weapon against action by the oil and gas industry.
You're done with lunch, right?
It's very
You're having lunch first?
Rebecca, I'm gonna mute you, sorry. So it's very important to understand kind of limits of data, sort of understand uncertainty in order to be able to respond to the kinds of arguments that suggest that means we should do less, which are the arguments that we will see from the oil and gas industry, and to be able to say that these are reasons for kind of more ambition.
Yeah.
But also that those are arguments that African states ought to be using in their engagements with the oil and gas companies that are coming in to do work within their borders, in their engagements with their kind of trade negotiations with other states. Can I just say a big thank you to Craig and Justin for your time. I think this was really kind of useful and interesting. We are putting together a database of useful resources and materials that you can draw on. It'll include some of the research and reports that Justin and Craig have been pointing to. And if you have something that you think should be in that database, please share it with us. I also, a little bit of advertising. Our next seminar is going to build on this one, I think, Joyce, this endpoint especially around science, economics, and human rights, that intersection. That's happening on the 5th of March at 3 p.m. SAST. It's going to be led by Joyce, which is fantastic. So please do register for that, come back to that. Thank you again, Craig and Justin. Thank you to everyone for being here.
Appreciate it. Thank you.
Thank you. And if there are more questions and concerns and you want to talk about anything, please do just reach out to me or Z, and we will certainly put you in touch with the people who can guide you as you write your briefs. Thank you.
Thank you so much. Thank you.
Thank you.